Fog computing is an important research area. It's a natural extension of cloud-centric model. We're interested in supporting fog computing using data flow coordination. Node-RED is a powerful data flow-based programming tool, but it was not designed for distributed fog applications. We built distributed Node-RED, or DNR for short. It helps build fog application using Node-RED. Here is the DNR editor. It has several extra functionality for programming and running a distributed cluster of Node-RED. Link constraints specify how multiple instances of nodes communicate. Node constraints tell on which device a node should be executed. Here I show how to create node constraints. First, you give it a constraint ID, which should be unique for the current flow. You can specify properties of the device a node should run on, such as name, location, or computing resources. For example, here I create a constraint with location. To edit an existing constraint, select it from the constraint list without selecting any node. Here I use just device name for the sake of simplicity. This constraint restricts the execution of a node to only device name Pi16. Here is the DNR menu. You can show or hide the constraints from the canvas. Here is another interesting feature, Device Monitor. This panel shows all Node-RED instances that join this DNR cluster. It also has a map view as well. Alright, let's see how a Node-RED instance can be connected to the cluster. The idea is that each Node-RED instance will run a special node that connects it to the cluster in the background. You can export that special node from DNR editor, and on each participating Node-RED, import that special node into it. Our special node is called DNR daemon. After importing DNR daemon to each Node-RED, you have to configure the daemon with the local Node-RED's information. This information allows DNR daemon to deploy and run DNR flow locally. They include the name, credentials, as well as the location of the local Node-RED. After deploying the DNR daemon, it will register with the cluster head, the DNR editor we've seen before. Here is our DNR editor again after I connect 4 Node-RED instances to the cluster. From the device monitor, 4 Node-RED instances have joined, and the map shows their configured location. Here comes the demo. We will use a TI sensor tag to control 2 CPU fans. We have 4 Node-REDs running on my laptop, my cloud server, and my 2 Raspberry Pis. Here is the real setup. The Raspberry Pi named 18. The fan it controls. And Pi16. Alright, let's review our DNR flow. In this flow, the sensor tag node is constrained to run only on my laptop. 5 nodes in the middle who process the sensor tag button output and log the outcome are constrained to run on my cloud server. Here you can see when I click the left button, 2 fans are on. It's worth noting that the Pis don't have Bluetooth connection. The button clicks are sent from my laptop via the cloud and ended up as PWM pulse to control the fans from the Pi. Now I'm gonna add a node constraint to the PWM node to have it run only on Pi16, which should prevent the Pi18 fan from running. Here we go. Now, let's try to switch between these two. I'm going to create a new constraint for the Pi18 device. Here we go again. Alright, here is the debug log from my server Node-RED. You can see my server Node-RED also connected to the cluster and is playing its part. Hopefully by now you got the idea of distributed Node-RED. Interesting in how it works. Whenever a flow is deployed from DNR editor, it gets pulled by all participating Node-RED by DNR daemons. DNR daemon also transforms the DNR flow into standard flow that Node-RED can run. It replaces unknown nodes with DNR placeholder that do nothing and inject the little coordinator nodes into every wire. These connector nodes coordinate the data flow between every two nodes. It can intercept messages, send them to external devices, or fetching data from external devices and send it forward. For more information, you can have a look at these publications. That's the introduction of our distributed Node-RED.